Hey, welcome. So, every single day, businesses are swimming in this sea of messy, raw data. The big challenge? It's turning all that chaos into a clear, visual story that actually helps you make smart decisions. And that's exactly what we're going to tackle in this explainer: how to make that journey from just noise to real insight. Let's get started. This quote from the legendary statistician W. Edwards Deming, man, it just nails the whole point of what we're talking about. It's the core of everything. This is what separates a gut feeling from a fact you can actually prove. It's the huge difference between saying, I think this is true, and I can show you that this is true.
And that's the big question, isn't it? If we don't want to be just another person with an opinion, what do we actually do about it? Well, the answer is you've got to get the right tools. You have to learn how to understand the world through the language of data.
All right, let's dive right in. We're going to start by building the foundation, exploring those core ideas that let us move past simple guesswork and start making decisions that are truly informed. So what is statistics really? It's so much more than just complicated math. It's a whole scientific process. It's about collecting the data, analyzing it, interpreting what it means, presenting it in a way that makes sense, and organizing it all. It's this structured method that lets the data tell a clear and, more importantly, a reliable story. Okay, so that's the theory. But where does this stuff actually show up in the real world? Because statistics isn't some abstract thing you only find in textbooks. It's the engine running behind the scenes of countless business decisions every single day. Just take a look at this. In accounting, it's used to see how what you plan to spend lines up with what you actually spent, which is perfect for spotting problems. In finance, it's absolutely crucial for managing risk, like figuring out the odds that someone might not pay back a loan. And for economists, it helps us all understand the big picture, like job trends, which every business needs to know to plan for the future. But before we can do any of that cool stuff, we have to learn the basic grammar of data. We need to understand what kind of information we're even looking at before we can start trying to figure out what it means. Basically, data comes in two main flavors. Over on the left, you've got categorical data. The best way to think about this is as labels or names. It describes a quality, like a genre of music or a customer satisfaction level. Then on the right, you have quantitative data, which is all about numbers. How many or how much? Think revenue, temperature, or the number of things sold. And this is where it clicks for a lot of people. Music genre? That's a category, a label. Customer satisfaction, even if you rate it 1 to 5, you're really putting it into categories like happy or unhappy. But temperature, revenue, the number of transactions, those are numbers you can actually measure and do math with. They're quantitative. Distinguishing between labels and numbers is the key here. Okay, so we get the different types of data, but what happens when you're just staring at a huge, messy pile of numbers? This is where the fun begins. This is where we learn how to turn that raw data into a story that actually makes sense. Let's make this real. Imagine you're the manager at Hudson Auto Repair. You've got a list of the parts costs for 50 recent tune-ups. Right now, it's just a long, meaningless list of numbers. It's just noise. You can't glance at it and learn a single thing. So the very first thing we do is try to create some order out of that chaos. We group the costs into buckets, repairs that cost between $50 and $59, $60 and $69, and so on. Then we just count how many repairs fall into each bucket. This is called a frequency table. And right away, we can already see something taking shape. The most common cost is somewhere in that $70 to $79 range. And then, boom. This is the magic of visualization. The second we turn that table into a simple bar chart, the story just leaps off the page. All that noise is gone. We can instantly see that most of our parts costs fall between $60 and $80 with a really clear peak in that $70 to $79 bar. And if we want to boil it all down to just one single number to summarize those 50 data points, we can calculate the average, or the mean. For Hudson Auto, the average cost of parts for a tune-up is $79. Think about that. In just 3 simple steps, we went from a totally meaningless list of numbers to a clear, actionable insight. So everything we've done so far with the Hudson Auto data, that's what we call descriptive statistics. We were just describing a set of data we already had. But what if we want to understand something about all tune-ups everywhere, not just our 50? Well, that brings us to inferential statistics, which is kind of like learning to make really smart, educated guesses about a huge group by studying just a small piece of it. Okay. First up, we need to talk about the population. This is the entire group we want to know something about.
So for Hudson Auto, the population might be all the car owners in their city. Trying to study every single one of them?
Yeah, that would be pretty much impossible.
And since that's impossible, what we do instead is take a sample, which is just a smaller, manageable piece of that population. In our case, those 50 invoices, that's our sample. The whole point of inferential statistics is to use what we learn from this small sample to make a really confident guess about the entire population.
Now, there are basically two ways you can go about studying that sample. In an observational study, you're a passive observer. You just watch and record what's happening, like someone taking notes on how long shoppers spend in a store. You don't get involved. But in an experimental study, you actively change something to see what happens. The classic example is the Salk polio vaccine trial, where one group got the vaccine and another got a placebo. That allowed scientists to prove that it worked.
So all these things we've been talking about, data types, samples, populations, they might seem basic, but they are the absolute foundation for some of the most powerful technologies that are shaping our world right now. You hear data science thrown around all the time, right? Well, think of it as the superhero version of everything we've just discussed. It takes all these statistical principles and combines them with serious computing power to pull knowledge out of all kinds of data, not just tables, but images, text, you name it. And then there's big data. The name kind of gives it away, right? We're talking about data sets that are just mind-bogglingly huge. Analyzing this data using the same techniques we've covered, but on a massive scale, is how companies uncover hidden patterns in everything from their supply chains to how we all behave online. And if big data is the giant ocean, data mining is like being a treasure hunter. It's the actual process of sifting through all that data to find specific, valuable, and hidden little nuggets of information, like how a grocery store might discover that people who buy diapers on Thursdays also tend to buy beer. That kind of insight can give a business a massive advantage. So look how far we've come. We started with a simple quote about opinions and ended up at the building blocks of data science. We've seen how you can organize noise into a real story and how to use a tiny sample to understand a huge population. You've got the fundamental tools now, so the only question left is, what story are you going to find in the data?